There's a good reason the world produces nearly 4 million tons of lead every year. We find it just as useful as our ancient ancestors did, who revered it as the father of all metals. Today, over 600 million drivers around the world depend on it every time they turn their ignition keys. An astounding 80% of all the lead we use ends up in lead-acid batteries. The battery under your hood consists of cells containing lead plates. Each plate is comprised of a lead grid and a lead oxide paste coating it. The plates, half of them positively charged, the other half negatively charged, sit in a bath of sulfuric acid. The acid causes a chemical reaction in the lead, creating electric current. To reduce manufacturing costs, most car battery makers use recycled lead and lead alloys that contain hardeners like calcium for their grids. These substances contain impurities that make the lead corrode faster in its harsh acid environment, which eventually causes the battery to fail. EnerSys Energy Products in Warrensburg, Missouri makes a longer-lasting, more reliable battery. And the secret ingredient is virtually pure lead.
This is 99.99% pure lead. From here to the end of this row represents 1 truckload of lead. So this is 2,500 pounds right here. You don't get very much on a truckload.
EnerSys pure lead batteries are designed to provide the ultimate in dependability, the kind hospitals and communication networks use during power outages. But the company also makes one you can put under your hood, called the Odyssey battery. The pure lead, however, is just one reason why it's a cut above. The lead plates made here are just over 1 millimeter thick, up to 5 times thinner than those in conventional car batteries. A thinner plate allows EnerSys to fit more plates into each cell, and that can make a huge difference.
More plates mean more surface area. More surface area on the plates means that it's able to deliver more energy faster, and that means more reliability in starting your vehicle.
The plate-making process begins with 1-ton blocks of lead called sows.
These sows will be transferred into our melting pot at 500 degrees C, and then the melted lead will be used to form battery grids.
Once the molten lead hits this rotating drum, which is slightly cooler than lead's relatively low melting point of just 621 degrees Fahrenheit, it quickly solidifies. Reel after reel, each holding 1,700 feet of lead, wait in line for the punch that will form the grid.
The material here is passing through a reciprocating die, which is punching holes at about 500 strokes a minute. It comes out the other end as a clean punch grid. If it didn't have holes, there'd be no room for the active material.
The active material, the lead oxide paste that will coat each grid, is applied further down the production line.
So paste is being dropped from the pasters, which are above us. They're coming through this tube system, and they're being applied to the grid so that you have a layer of grid with a layer of paste on top of it. It then goes into the roller where a sheet of pasting paper is applied. The purpose of the pasting paper is to prevent the lead from becoming airborne later on as the plates start to dry and the lead oxide becomes a powder.
Next, the plates are cut, weighed, and flattened. Then, after curing for several hours, they're encapsulated into individual battery cells. But still more lead is necessary to complete them. Robots dip each cell into a shallow pool of molten lead. There, tabs protruding from each plate fit into steel molds. Within 15 seconds, the molten lead solidifies. This lead connects each plate to the next, ensuring that electric current can pass between them. Finally, the cells are welded together into a single battery. Machines inject the sulfuric acid, and the battery receives its first charge.
The higher reliability batteries that we provide, even though they do cost a little more, it does increase the reliability of your vehicle.
Centuries before we were getting a charge out of lead, ancient civilizations recognized its value and versatility. From roofing material over the gardens of Babylon to facial cosmetics of Egyptian pharaohs, Chinese coins to the type on Gutenberg's revolutionary printing press, lead has aided in our existence for nearly 6,000 years. But it was Roman engineers that first used lead on a grand scale. They took advantage of one of lead's key properties, its malleability, by shaping it into an intricate network of pipes that delivered water to the imperial capital. The vast plumbing system inspired the Romans' Latin name for lead, plumbum, which is why lead's atomic symbol is Pb. Lead had another property the Romans exploited to make drinking wine more pleasurable, despite the fact that many even then knew of lead's toxicity.
I cringe when I think about this, is they used it to make wine sweeter. Romans would boil wine in lead vessels. The lead would form a compound called lead acetate, and that has a sweet flavor.
Some historians believe that drinking lead-sweetened wine and water flowing through lead pipes may have so debilitated the Romans that it contributed to the empire's fall.
The reason why it was suspected that lead could have had an impact on the decline of the Roman Empire was that there was so much lead around at that time, but in fact there was so much limestone in the water that the lead pipes would have been coated with limestone inside, so the amount of lead therein wouldn't have been enough to expose them to so much lead that their reproductive systems would have failed completely, or they would have gone completely mad. So there just wasn't enough lead to go around Rome to make the empire fall.
While lead poisoning may not have brought down an empire, the potentially deadly neurotoxin poses no less a threat today. If you ingest or inhale lead, most passes from your body within a few weeks. But your body mistakes some of it for calcium, a vital mineral nutrient, and stores it in your bones. Whenever the bones release calcium into the blood, responding to your body's needs, the lead joins it and can make its way to any of your organs. The most vulnerable of all is your brain.
When lead gets into your brain, it keeps calcium from doing its job, helping your nerves function properly. That causes brain damage and damage to the rest of the nervous system as well.
Although lead in high enough doses can do irreparable harm, it can also protect you from a dose of another kind. Light Tech Incorporated near Philadelphia, Pennsylvania, produces lead aprons, the kind you wear whenever you have an X-ray. Lead's high density and low cost have made it the ideal apron material for decades.
There are many different styles of apron. This is perhaps the simplest one. This is a frontal protection only. This might have 6.5 pounds of lead powder in it. When we get into higher exposures, either for time reasons or because the energy of the beam is much higher, typically in cardiology or cardiac catheterization, we're into a two-sided apron, front and back. This apron would have about 12 pounds of lead in it.
Light Tech's aprons contain as much as 85% lead powder. The remainder consists of a variety of plastics that make the aprons flexible. The proprietary mixing process takes 20 minutes.
This is a sheeting line which is converting the mixed material into a sheet, a very thin sheet, a very controlled sheet. The material is, this case, is about 15 thousandths of an inch. That is to make it heavy enough, stop the radiation, but light enough so it's not too heavy for the doctor to wear. And one batch of 240 pounds from the mixer will make approximately 2 rolls. These rolls weigh about 120 pounds.
Quality control supervisors cut out and weigh samples taken from the beginning and end of each roll.
We don't want it to be too thin where it doesn't protect. We also don't want it to be too thick where it's heavy.
In Light Tech's sewing room, workers stack the sheets up to 4 layers thick, depending on the level of protection needed, and cut them to size.
The lead is soft. It's a lot easier to just cut through like that. It slides right through. It's kind of like a knife through butter.
Finally, they stitch the lead into vinyl coverings. And another lead apron is ready for your next X-ray exam. But what's precisely happening to those X-rays when they hit the lead?
They can actually come in rather like a pinball machine. They can bounce off the lead atom, lose energy, and then pinball off another atom of lead and reduce energy again until all the energy is dissipated. And there's no change to the lead.
Before lead can make its way into the X-ray room or under our hood, we've got to extract it from a dark world 1,000 feet underground. In 2005, Department of Energy researchers examining bone fragments of Ludwig van Beethoven determined that his chronic abdominal pain, irritability, depression, and death were caused by lead poisoning. Lead will return on Modern Marvels. Mining and smelting metals is a challenge measured not only by its technological complexity, but also by its environmental impact. This is especially true for a neurotoxin like lead. Only one primary lead smelting facility remains in the United States, in Herculaneum, Missouri, where a succession of companies has operated since 1892. In recent years, the smelter has become a focus of controversy as America tries to balance its dependence on lead against the environmental consequences of producing it. But the smelting operation is just one part of a complex process that begins at sites like this one, the Brushy Creek Mine outside the small town of Viburnum. Each morning, workers descend 1,000 feet below the Earth's surface to mine lead. The mine, operated by the Doe Run Company, is one of 6 lead mines far beneath southeastern Missouri's Ozark Mountain region. Over the past 5 decades, miners have carved out this vast underworld, tapping one of the largest deposits of lead ore on Earth. They extract about 6 million tons of lead ore every year.
Most people think that we mine straight lead, and that's not necessarily the case. We mine galena.
The main ore of lead is galena, lead sulfide. It is made up of about 87% lead, and the rest is sulfur.
The formation of this deposit began more than 500 million years ago, when Missouri was under an ocean featuring a porous tropical reef. Over time, the ocean waters receded, the Earth's crust shifted, and mountains formed over the exposed reef. As warm groundwater migrated towards the mountains, it picked up minerals, including galena, and deposited them in the countless pores in the reef.
And it looks just like this when it's in the ground, in the host rock.
The lead mining process begins as hydraulic drills bore blast holes 14 feet deep into the ore face. A steady stream of water forces the loosened rock from the holes. After 2 hours, 65 precisely placed holes are complete. Most blast holes are about 2 inches in diameter. But within the center of the face, the drills bore larger holes to leave room for the exploding rock to expand.
The rock has to have somewhere to break. It would kind of be like blowing up a balloon in a coffee can. There's really nowhere for the rock to go. So we'll usually drill 3 larger size holes in the center, right dead center.
The crew loads each hole with explosives containing the appropriate time delay blasting cap. Blasting caps are numbered in accordance with their time delay. They increase outward from the center and detonate in a rapid-fire sequence. This will force the rock to cascade towards the center of the face. Once the area is clear of miners and machinery, the crew chief initiates his safety fuse and has 2 minutes to retreat to a safe distance. A half-mile behind him, lead locked in place for 300 million years is about to be blasted free. When the dust settles, miners enter the blasted area and scrape any loose rock from the walls. One blast creates 500 tons of rubble, 5% of which is lead. 2 hours later, a second crew moves in with heavy machinery to haul it away. Lead in this form poses little threat to the miners, since it hasn't had a chance to react with the atmosphere. It's considered to have low bioavailability, which means the body doesn't easily absorb it. But as a precaution, Doe Run miners are required to have a blood lead test once a year. After the ore is crushed, it ascends to the surface in buckets called skips, 9 tons at a time. Then it's up to the mill to get the lead out.
The job here in the mill is to take the ore that comes from underground. It typically runs about 5% lead. We process that and produce a concentrate that has about 80% lead in it.
After undergoing further crushing here, the ore fragments enter these rotating cylinders. Inside, they tumble with 80 tons of steel rods, 3 inches in diameter, which pulverize them.
This is where we add water, so from this point on, the ore goes through the mill as a slurry. We also add the chemicals for the flotation process. This is a lead flotation circuit.
In the flotation tank, both a chemical and physical process occur. Chemicals latch onto the lead minerals, and air bubbles introduced into the tank float the bonded particles to the surface.
So what we see here is lead mineral floating over the sides of the flotation machine.
That's right. You're actually seeing this heavy metal float. At this point, the lead concentrate is diluted with about 80% water by weight. Large vacuum filters suck most of the water away, resulting in a concentrate 93% solid. On average, 60% of the concentrate produced here makes its way by covered truck to Herculaneum and the primary lead smelter, which the Doe Run Company has operated since 1986. The other 40% is sold worldwide.
The primary purpose of the facility is to convert lead concentrate into lead metal.
Loaders kick off the process by transferring each truckload of lead concentrate to a rail car. Every 100-ton load enters the facility, and the first challenge is to remove whatever traces of sulfur remain. A furnace known as a sinter machine burns off the sulfur by heating the concentrate to 1,500 degrees Fahrenheit. This converts the concentrate to lead oxide. In this form, it's more easily absorbed, so the workers here wear protective gear. The lead oxide moves to another furnace, where a mixture of carbon and oxygen generate a more intense heat of 2,500 degrees. This creates the proper conditions to convert the lead oxide to metallic lead. But smelting a metal that's also a neurotoxin produces emissions that carry inherent environmental risks. Although Doe Run has reduced its emissions here significantly over the past 2 decades, its smelting operation has often failed to meet state and federal environmental standards. Lead has contaminated the yards, homes, and children of Herculaneum's residents. And according to the New York Times, Doe Run has spent millions in cleanup efforts. The company continues to face criticism about its environmental track record. But our need for lead continues. And each year, 150,000 tons or more of lead emerges from this facility. Not all of Earth's lead has lain around for just a few 100 million years like the ore mined here. Much of it began its life over 4 billion years ago as a different, unstable element.
Lead is the end product of radioactive decay. Uranium decays into lead. A lot of other radioactive elements decay into lead, and that's where a lot of our lead comes from.
It's that decay which allows scientists like Dr. Roland Mundell to use lead as a key to unlock secrets of Earth's past. By determining the proportional amounts of uranium and lead within a rock sample, Dr. Mundell can calculate the sample's age.
An hourglass is a good analogy of what is happening with the uranium-lead system or any isotopic system. In this case, if we consider the upper part of the hourglass being uranium and the lower part, the decay product, the lead, we can then precisely determine an age. So, for example, where we have a lot of uranium and very little lead accumulated, those would be relatively young ages. where we have very little uranium left and a lot of lead accumulated, we would have very old ages.
This powder is a crushed volcanic rock sample from Australia. Determining its age will tell scientists precisely when a mass extinction occurred during the Earth's Permian period. The first step in dating it is to isolate microscopic traces of lead and its unstable uranium parent. Magnets separate the granules that contain no lead.
What we are interested in is the non-magnetic fraction right here, which contains tiny little amounts of zircon minerals.
Next, the lead-bearing minerals enter a solution that separates them from lighter minerals. The lead-bearing ones collect at the bottom. The most pristine of these isolated minerals, seen here under a microscope, will undergo a crucial treatment.
The next step is adding a known amount of tracer solution, which contains artificial isotopes of uranium and lead. And in doing so, we can then later back-calculate the ratio of uranium to lead in our sample.
Later in the process, the microscopic traces of lead and uranium are loaded onto a turret, which then enters a device called a mass spectrometer. The machine determines precisely how much uranium and lead exist within the sample. This enables Dr. Mundell to determine the sample's age.
For this volcanic rock from Australia, we calculate a uranium-lead age of roughly 259 million years, with an uncertainty of plus minus 400,000 years.
Just as a few particles of lead can help us understand Earth's past, it takes little more to imperil our future. According to the Minerals Information Institute, today's average American will require 911 pounds of lead during their lifetime. Lead will return on Modern Marvels. According to the Department of Housing and Urban Development, 1 in every 4 American homes contains significant lead-based paint hazards. When the paint deteriorates, it frees chips and dust to contaminate everything in the area. Those most at risk are children.
A child under the age of 6 exposed to lead absorbs it at twice the rate as an adult. And so it affects their nervous system and it may be detrimental to their learning capabilities in the future.
This lead abatement team in Los Angeles, California, is among many nationwide addressing the problem. Its job is to remove the lead that until 1978 was added to paint to reduce corrosion and as a pigment to increase brightness. The team's target today is the house's exterior. The interior work will follow, but first a specialist must determine how much lead the paint there contains. His X-ray fluorescence lead paint analyzer, or XRF, measures the milligrams of lead paint per square centimeter, even if several lead-free paint layers are covering it. In LA County, an XRF reading higher than 0.7 is considered a lead paint hazard.
And here we have a ceiling. It's damaged. The paint is damaged. It's chipping, peeling, has some mold damage. The reading is 9.6. That has a significant amount of lead in it and should be treated. One of the major areas of concern for lead-based paint hazards are friction areas, such as window sashes rubbing up against window jambs, window sills. That friction creates a fine dust that children can get their hands on. Hands can go in the mouth and they ingest the lead that way. And this one is not in the greatest shape, and it's, and has a significant amount of lead in it.
Outside, the abatement team removes the lead paint on the house's exterior using only water and scrapers.
We spray it down to keep the dust particles down. We're not allowed to do any mechanical sanding because of the amount of dust that gets created. So pretty much everything has to be manually scraped on a house like this.
Once the scraping is complete, a vacuum sucks up the paint chips and dust for proper disposal. To contain the remaining lead paint that can't be scraped away, the crew sprays on a special coating called encapsulant.
It bonds to the lead molecules. It has a 20-year lifespan, and it has something else called bittermite in it. It gives it a bitter taste, so if a child wants to fight or finds a flake or have that bittermite in it, it'll give them a sour aftertaste. The taste will probably stay with them for about 2 to 3 days, so they'll know not to eat that again.
Lead-based paint removal from houses is an ongoing effort, but a significant amount of lead still remains in our soil. And it didn't all come from deteriorating lead paint. Most of it spewed from our cars as exhaust, starting in the 1920s, when oil companies added it to gasoline to help prevent engine knock. Gasoline in an internal combustion engine is designed to ignite when the pistons complete their stroke at the top of the cylinders. But gasoline in early engines often ignited prematurely, causing an audible knock or ping vibration and reduced efficiency. Adding a compound called tetraethyl lead to the gasoline solved the problem by helping the air-fuel mixture to burn more evenly. But it also released harmful lead particulates in the engine's exhaust.
50 years of lead was going into the atmosphere via the tailpipes of our cars. So there was leaded gasoline sitting there on the blacktop, eating it away, washing off in the next rainstorm into the water supply. Lead doesn't go away. It just stays there. Since the 70s, when lead was outlawed as a gasoline additive, lead levels in the blood of the American population have gone down 75%. Amazing.
Over the years, we've learned there's value not only in outlawing or disposing of lead, but also in recycling it. America recycles more than 1.2 million tons of lead per year at sites like Doe Run's Buick Resource Recycling Facility in Missouri. Every day, 50 truckloads of lead-bearing materials arrive at the plant, from spent ammunition to pipes and wheel weights to cathode ray tubes.
This is a CRT or cathode ray tube that might come from your computer or a TV screen. This is a 17-inch screen right here, and it'll contain about 25 pounds of silica, about 2.2 to 2.5 pounds of lead. During the year, the recycling plant is going to feed through about 8.9 million pounds of CRT material and recover about 500,000 pounds of lead.
But this and the rest of the lead-bearing scrap accounts for only 15% of what's recycled here. You can probably guess what makes up the other 85%.
The majority of our feeds are batteries, lead-acid batteries. About 14 million of them this year.
The 18 pounds of lead in the typical car battery must be separated from the sulfuric acid in the battery case. Inside this bunker, a loader dumps the spent batteries into a crusher. Its stainless steel teeth shred 30,000 batteries every day. But gallons upon gallons of acid collect onto the floor for later processing. At this point, a chemical process is used to remove a majority of the sulfur remaining in the lead. Chemicals added elsewhere in the facility will remove whatever traces linger. Then those chemicals must be burned off in a furnace. The molten lead exiting the furnace still contains some impurities. So workers in the refinery follow a detailed process to remove this so-called dross.
We'll use chemicals such as sodium nitrate and sodium hydroxide to remove materials that we're able to oxidize out of the lead. Those materials will float to the top, and then we'll use our overhead crane and our operators to manually remove the dross from the surface of the lead. Once we've removed the dross, we basically have a pure lead alloy, which is ready then for further processing.
From the refinery, a propane-fueled trail of fire keeps the lead in liquid form and feeds it to the casting area. Within seconds, each ingot solidifies.
This is an example of our 60-pound inline casting machine. This lead will be bundled into 2,000-pound bundles, and then it'll be sent to our customer for final consumption.
Who knows? With 1.2 million tons of lead recycled each year, the lead in your old computer monitor might end up starting your new car. But not all of our lead lives an industrial life. It has an artistic purpose as well. More than 97% of lead-acid batteries are recycled, almost double that of the next most recycled products, aluminum cans, with only 55%. Lead will return on Modern Marvels. In the 13th century, small balls.
So color gray, but in so gray for
mold and X all this
with a 50 caliber round ball and the
pile outside barrel. It goes straight on a version of lead. In the recent invasion, lead-free green molds or tungsten nylon. Spray still very little use to make both and glass still carry. Starting Michelet's pieces.
We call it legally as a minimum percent and maximum effective process is 30%.
With lead glass, the crystal becomes solid and spread. Lead is becoming locked in glass. When it heated underneath, the bond between lead and heating shipment. The super tanks and ability to run a lot more than that last. Increased books in metal slash, but you need to carry on the house.
In the glass, the distinction of the and she made her regular and together. And these are hand-blown crystal and quality of the homes. Cheaper and longer.
Under that properties is by on over
It's nice to raise to feel softly and watch it last. But is it brittle? The glass very naturally
The bill has been back. Percentage of lead mass.
Your last line is determined of negative. Different to always but you can compare.
Glass. Inner panel. The pieces are held in spiral shirts called substitute material. And suitability comes in an example. Your first tree. Artisan in San Diego, California. In Gerald Florida.
I don't know either how that as well. We form it, we shape surface with value for us.
Our epoch is full of design or images of fancy. Monday glass, unfortunately, is and in the splitting sauce of the Jesus. Substitution mix. But for at all is assembled. These letters help to
but as far as having or being somebody of any harm to
the intervals on the eye was here. And yes, the guidance is on whistle and system and for city at Starbucks over on moon and this one over on Mars. Let's assume continuously at least $1,000. Only after the offer in me and a book in the castle pottery or it likes owls and own office. The issues that need songs here producing her future matches. Always upsetting or song letter. Let the song and I've seen that better, sir. So it is instead. A mission of bottom is our lesson of the urban still is located at 6 Austin Martin Mark. The person you met with me is married. The Honey furnace. Lead is in use at 700 degrees. Zeroness. Curtis Aerobal wax. Made of purified salt ash.
Glass and metal bear solid bodies that are left metal at the top.
Acting on the trace. Resemble metal cooled by 400 degrees. Then pour it off. And don't take covalent. She slides and show less from the dead and saw metal from the dead. After store to monstrous things, cruise such like a surface. Their light is perfect. More like metal is orbital. Acid to their plants, rolling in the mid-shape, engine steam tar. Then the bush and sequence. The iron slit with all the mouth.
That's the fire to success. It would be carried by the motor part. The composition has the advantage of being soft enough for the laser to cut away to just soft for that, but strong enough and responsive enough to make for good sounds.
Solid discussion with the motorbike sound. You could hear compressed air and breath. It's go back and hold the bag and dust the seat a lot further. The swingers going.
A little soft. So
A permanent set of tuned pipes on the back row of the voicing machine provides a reference pitch.
Pipe is flat.
He finishes his voicing work by trimming the pipe's length and adjusting its so-called tuning collar.
I activate that pipe and listen to it with the one in the front and listen for beats to see if they're in or out of tune.